Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're going to talk about one of the most important things that you need to know when it comes to being an audio developer, which is about the AudioBuffer class, how audio actually gets into and out of your audio app. So we're going to discuss a little bit about what the AudioBuffer is and about some of the basics around how to use it. Before we get started, if you like this tutorial, be sure to check out our Patreon, where you can help support the audio programmer, where we can make more tutorials like these. And also be sure to check out our community on Discord, where we have loads of audio programmers of all different skill levels and all different levels of experience that are asking each other questions, networking, getting to know each other, and of course solving audio programming problems. So you can come join us over at theaudioprogrammer.com/community. It's completely free. Come join us and let us know about all the cool things that you're working on. So let's go ahead and get started. And I've got a really cool tool that we're going to try out today in a little bit. But first, we'll start off by making a new project. So I will just call this test project. This time we're going to make it an audio application, but the same sort of concepts apply if you're making an audio plugin. Just a audio app actually lets me just load and actually play sound from the Juce app itself. So I will just save this to the desktop. And now we have our test project. And so I'm just going to open this up. And here we have our source files. Just going to minimize all this and just get over to our main component.cpp. So this is the same thing as the plugin processor if you were working in a plugin. And the main function that we're going to talk about is this function here called getNextAudioBlock, which is where you do all of your audio routing. So any sort of DSP processes that you have that you're actually doing in your plugin would actually be going and happening in this getNextAudioBlock. And the most important thing to know about getNextAudioBlock is that it's a special type of function. So if you know a little bit about audio programming, then you know that one of the most important things about audio is that the audio needs to be continuously running through the plugin, and we don't want to do processes that jam up the audio data getting into or out of the plugin. And so the getNextAudioBlock is a special function that's specially designed to run at a very fast rate. So it runs quicker than any of the other functions that are happening. And this is to ensure that the data is always flowing through the plugin. So we see that we're given access to a reference of this Juce object called audio source channel info buffer to fill. So this is our audio buffer. So the buffer is what actually holds our audio information. And if you know some of the basics about audio, you would know that the audio is stored as a series of normally floating point or double values that are stored in what really is kind of like a vector, but with some special functions. So now what I'm going to do is, rather than trying to just code this out, I'm actually going to, I've got my iPad here, so I've got a new iPad, and it'll allow me to actually do some writing for you. And I'm going to actually be able to write some of this and draw. And even though my writing is really messy, I'm going to just try to explain this in writing, because I think sometimes it's better to write these concepts out rather than just trying to do everything in code. So if we're talking about audio buffer, and sorry about my messy handwriting, and I wish I could make this bigger, but this is actually the largest that this gets. So I hope this is big enough for everybody. And what we're talking about is a container that's holding our audio information. So it's holding these floating point values that are instructing our speakers on how they need to move forward or backwards. So what we're going to do is we're going to draw a little container here. So luckily I have a shape drawer that will actually smartly draw these. So I'm just going to draw a little thing. And I'm sorry that this is very crude, but I want to do this quickly as well. So here we have these boxes here. And what I will do is I will mark this one on the, so we will mark this as, so this is a 2D vector, right? So this will be channel 0, and we have channel 1. So this is a normal stereo setting. We have a left speaker and we have a right speaker, right? And in here we have sample numbers, right? So we could say that this will be samples, and we could make this 0, 1, 2, 3, 4, and this would go on to our buffer size. And in here, if we had audio information that was already coming in, so if there was audio, let's say we were making an audio effect that was sending audio information into the plugin, then we might have audio values that are stored in here. And normally these audio values need to be between the values of +1 and -1. So we could just put some values in here. So let's just put 0.3, negative 0.04, and 0.7 minus -0.2 and 1, right? So now we have some values in here. So there are a few special functions here that are important to know about if you're working in an audio buffer. So one of these might be how many channels we have, right? So in this situation, we have 2 channels. So we have a method that is called getNumChannels. And then another one that we might want to know about is getNumSamples, right? So this 2-channel buffer is going to have some sort of size. Okay, so let's say it's like 512. Normally it's like a power of 2, 512, 1024, but sometimes it's not. So sometimes we want to know, well, how many samples there are in the buffer, because we need to read through all of these samples and maybe we need to do something to them, right? So that's how we do that, by querying get the number of samples. So then another thing is that sometimes we want to just look at what information is actually coming into the buffer, right? So we have these values that's coming in, that are coming into our audio plugin, and sometimes we just want to say, we want to put those out through some sort of volume meter or RMS meter that shows the user what sort of levels that they're getting out of their plugin. So what we want to do is we might want to inspect into these values, but we don't want to change them. We just want to read them. So we have a method that's called getReadPointer. Ooh, not read pointer. And then there are other times where we actually want to change, or where maybe the buffer doesn't have any values in it, and that we want to actually change the value. So when we want to change the value, then what we want to do is we want to write a value. So we want a write pointer. And so we have this method called getWritePointer. So just to review, AudioBuffer is a container that holds our audio information. Normally we'll have a number of channels. So in most cases, if we're working in a DAW, then it would normally have 2 channels, channel 0 and channel 1. Then we have a number of samples that it holds. So this is in this particular situation, we're talking about a 2D vector. So we have channel 0 and we have channel 1, and then we have a number of samples that the container is going to hold. So a lot of times it might be something that's a power of 2, like 512. But like I said before, sometimes it is not. We have a couple methods that we can use to actually query these things in code. So we have get number of channels, where we might want to go through the number of channels that we have, and then get the number of samples, where we want to find out how many samples we have. So if you think of a for loop, we might want to have a two, what they call it, 2D for loop, I guess. What's the word? The phrase is kind of escaping me at the moment, but one for loop inside of another for loop, where the first for loop you're going through the channels, so channel 0, channel 1. Then the second for loop you're going through the samples, 0, 1, 2, 3, all the way up to the number of samples. So I think that I have explained everything. I feel like I'm missing something, but maybe I'll come back to it later. So yes, so now like if we think of something that we could do. So one of the most basic things that we could do in order to, let's say we don't have any sort of audio information that's in the buffer already, but we want to put some information in there, right? So the easiest thing that we could do is we could put random values. So let's say that we had some sort of random function and that we have these values that will maybe be between 0 and 1 or between -1 and 1, right? So we could make it like that. And that what we could do is we could use our right pointer. So what we could do is we could get a right pointer that will get us permission to actually write to these index values. And what we could do is we could take and we can put these random values in there. And what we'll get is white noise. Okay, so now let's go ahead and try that out in code. So going back here to our code itself. And what I will do is I will pull up the handy Juce API so we can actually take a look at the class itself. And there are a lot more things, more complicated things that you can do with audio buffers. Once you get the hang of them, you can actually create another audio buffer. You could use that kind of as a temporary buffer to store something and then copy it over to your main buffer, or you can mix two audio buffers together and have kind of a wet-dry effect. There are loads of different things that you could do with those. So yeah, scrolling down here, as I was saying, here are some of our methods. Get number of channels, returns the number of channels the audio data contains. Get number of samples. Get read pointer, get write pointer. So those are some of the most important functions here. Going back into our get next audio block, the first thing that we want to do is we notice that our audio buffer, so this is an audio buffer object. It's called audio source channel info. So to get access to the buffer itself, we just need to go in and actually find the buffer itself. So what I could do is I will do that now, and we will say auto pointer buffer equals buffer to fill dot buffer. And so this is the buffer itself. And these are kind of setup variables that I normally set up when I'm starting a new audio project. So helpful variables that I set so I don't have to write buffer to fill dot buffer every time, right? We could say auto num channels equals buffer. And remember, this is a pointer, so we need the arrow operator. Get num channels. Then we have auto num samples equals buffer. Get num samples. So that's going to give us the number of channels, number of samples that we have. And now what we could do is we can actually start going through the buffer, going into the buffer, and we can actually start either reading the information if we have information coming in, or we can start changing information. So let's create a way that we can actually do a little random function, right? So we could say 4, auto I equals 0. Actually, I will call this channel, right? So this makes it nice and intuitive for us. Channel is less than number of channels. So what we're going to do is we are going through the number of channels we have, and then we will iterate over those. Nested is the phrase that I was looking for earlier. So for auto sample equals 0, sample is less than num samples, and now we're going to do plus plus sample. So we're going through the channels, we're going through the samples, and now what we could do is we can make our take random values and we can actually insert them into our buffer. So we will say, oh yes, I forgot. So what we need is we need a function to actually get permission to actually write into the buffer, right? So we could say auto, and this is a pointer. Even if you don't use pointer there, it will still compile okay, I think. And we could say this is our write pointer, and we could say buffer get write pointer. And now all we need to do is put in our channel. So we have channel, and see we're going to be iterating through channel 0 and channel 1 because this is a stereo setting. And now we have our write pointer, which is going to give us access to the channel. And now we just need to iterate through the sample in that channel. And now we just need to write our random functions. So let me pull up the documentation here. Sometimes I forget how to actually do this. So we have a Juce maths module here. And in here we have a random number generator. So we will click in here. And then what we want is next float. So this returns the next random floating point number, a random value in the range of 0 to 1. Okay, so that'll work fine. We don't need to worry about doing some fancy math to get it to go from -1 to 1. We will just leave it basic. So what we could do is we could create a random object. Remember, any Juce objects need to have the namespace Juce before it. And we will just call this random generator. And then going here, we could say random generator get next. Oh, do I got this right? Next float. Yeah, I always get those mixed up. So that will give us a number that's between 0 and 1 times, and we will just make sure we turn down the amplitude on this to make sure it doesn't blow our ears out. So I will put this to 0.2. I'll make sure it's cast as a float. And so now we have a random number generator that'll just put some random numbers into our buffer, and we should hear white noise. So just make sure you don't turn your headphones up too loud when I compile this, just to make sure that it doesn't blow your ears out. Okay, so here we go. And also make sure that that number is indeed 0.2 and not 2.0 or something like that, or it will be very loud and very unpleasant for you. So we don't want to do that. So just taking a minute to compile. Of course, there's not going to be a UI or anything. It's just going to be very basic. And so we hear the white noise. And that is really what it's all about. So just to pull our little drawing back in here, just to kind of pull it all back together again. Remember that we have a number of channels that are in our buffer. So our buffer is a container. It's going to hold a number of channels and a number of samples. So this is like a 2D vector. Not exactly like a vector, a little bit different, but basically like a vector that's going to contain floating point values, or in some situations maybe double values. And as we can see those these values in here. Sometimes we want to change them, so we can change them. If we have a DSP process, if we want to put a delay on them, or if we want to maybe use filtering on it, then we would use get right pointer, because that will allow us to actually change what's inside the buffer. But other times we just want to inspect what's actually in the buffer, what's the numbers that are actually in there, but we don't want to actively change them. And that's when we could use a read pointer. Then you have these helper methods such as get number of channels, which gets us the number of channels. We have get number of samples, which will tell us the size of our buffer. And that's really it. Okay, so those are some of the basic fundamentals that you really need to understand for doing anything with audio, really. So any sort of audio app, any sort of plugin, you need to understand these concepts. And I hope that was helpful for you. If it was helpful, be sure to give this video a thumbs up and subscribe and all that good stuff. And I will see you next time.